All right. Thank you, Caleb. Thank you for your encouraging words. Thank you, Michael, for that motivation. Thank you so much. It is well appreciated. And thank you all for turning to class. Today is another great day, another wonderful day. Welcome. Thank you so much. Welcome back to class, all of you. We appreciate seeing you each and every day, seeing you work hard. We appreciate seeing you consistent. Some of you, it is very late in your countries, but you are still learning. And for some of the seniors, you've been learning for months and months and months and months every day. That's so wonderful. So thank you all, Ashinafi, Aglalui, Crankson, Enoch. Enoch, I think Enoch is from Benin, right? Enoch, are you from Benin? Welcome, David and Prosper. Welcome, Marvelous, Lucretia, Ato, Dachumo, Wildom. Yes, so welcome, everybody. Welcome, 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 and welcome to another wonderful session. Namfanelo, Israel, Adeduni. Welcome, welcome, welcome. I'm so excited to be here tonight, and we have something amazing to cover in the course that we are currently treating. So this is the AWS cloud computing course with CCP certification. And I'm going to be sharing my screen and we will begin our lesson for tonight. This is an interesting course. It's a very important course that will prepare you for the future and promote you in terms of your knowledge level, your understanding level, move you higher in your ability to comprehend technology, your ability to comprehend IT, and your ability to learn. This will prepare you for higher education. It will prepare you for advancement and prepare you to move forward. I've been in the tech field for so long. And so when something is important and something is a stepping stone, I see it. This is a stepping stone. This is important. This is going to make a difference in your future. It's going to make a difference in your career. And we are so excited to be here to go through this course. So if you are ready, let me see some ready in the chat. If you are ready for the class today. Yes, we have about 40 people in class. We are all ready, ready, ready. And one thing I'll say is that when you join the class, pay attention, do your best to understand, ask questions, and make sure that you are following everything we are treating. And this particular examination is an understanding-based examination. You will not succeed if you don't understand it. Yeah, so everything we are learning, we need to have the understanding. So this is not something that you just read and take an exam. It's an examination that will test your understanding. So it is very, very important. And AWS has a lot of techniques to get the data they want. Sometimes they introduce certain questions just to check whether you understand what you are answering, or you are just answering based on either past questions or answering based on very basic preparation. They know how to get that information. Yes, so make sure you get the understanding, and that is what we are here for. And in this particular training, our goal is to make the concepts easier to understand. Make it very easy to understand so that even if it is hard for you to research on your own, hard for you to read on your own and understand, In this class, our goal is to make sure you understand. In day one, we treated Introduction to Cloud Computing and Understanding Cloud Computing. This is day two, and day two, we want to zoom in into the doors of AWS, get into the world of AWS, and start exploring AWS. I'm preparing some animation to create an intro, but tonight I'm just going to say what I want to create certain slides and animation for. And once I say that and keep saying that every day, it will highlight some key terms and terminologies that we need to keep in mind, some key piece of information that we need to keep in mind. And so almost in every class, I'm going to play an animation or take you through some slides to cover some key information before the lesson begins. And so as we are ready, let's get right into today's lesson. Years ago, a woman in my neighborhood started a small provision shop. I remember it like it was yesterday. At first, she sold only 3 items on a tabletop: bread, milk, and eggs. She worked tirelessly day and night in the sun for months. Her hard work paid off, and soon she managed to put a roof and stands over the table. I have never seen anyone so dedicated. As time went on, she began adding more products and gradually expanding. After a few years, she could afford a small wooden store. She kept working hard, and eventually her store grew into a full-fledged supermarket with countless products. Today, it is one of the largest supermarkets, a one-stop shop providing over 200 different items that cater to everyone's needs, from low-income families to luxurious homes in the city. This story is exactly the journey of Amazon Web Services, AWS. When AWS started in 2006, it offered just 3 core services. Number one, it offered EC2 for computing. Number two, it offered S3 for storage. And three, it offered SQS for messaging. These were the essentials for developers and businesses just beginning to explore the possibilities of cloud. But as demand grew, AWS expanded, adding more services year after year and innovating to meet a broader range of needs. Today, AWS is like that woman's shop, transformed into a supermarket with over 200 cloud services that support businesses of all sizes, from startups to even giants in the industry. Today, when you enter that woman's supermarket, you may even feel a bit overwhelmed by the numerous products. Fortunately, the items are organized into various sections to make it easier to find. Similarly, AWS organizes its services into categories, each serving a different need. We have the compute services that provides EC2, Elastic Compute Cloud. It provides AWS Lambda, provides Elastic Beanstalk, provides ECS, Elastic Container Service, provides Lightsail, which is a user-friendly service for launching simple web servers, ideal for small businesses or beginners. In the storage category, AWS offers Simple Storage Service, or S3. We have EBS, Elastic Block Storage, or Elastic Block Store. We have Glacier, AWS Glacier. We have FSX, and we have Storage Gateway. In the database category, we have Relational Database Service, or RDS, DynamoDB, a special database platform called Aurora. We have Redshift and DocumentDB. In their networking and content delivery category, we have Virtual Private Cloud, or VPC. We have Route 53, the most popular CloudFront. We have Direct Connect, and we have API Gateway, which manages and deploys secure APIs, enabling seamless integration with back-end services. In their management and governance category, we have CloudWatch, CloudTrail, Systems Manager, and we have organizations. Understanding these core services of AWS is essential for the AWS CCP certification exam. In the course of our studies, we are going to be exploring these core services as it is vital for success in the examination. This examination is an entry-level certification that provides a foundational understanding of AWS cloud services and concepts. It is ideal for anyone starting with AWS or aiming for a broad understanding of cloud services in any tech role. The exam is structured to be multiple choice and multiple answer type of questions. There are about 65 questions, and the duration is 90 minutes. The passing score is 70%, and the exam topics are categorized as follows. We have 26% of cloud computing concepts. We have 25% of security and compliance concepts. We have 33% of AWS core services and technology. And we have 16% of billing, pricing, and support. In this course, we will cover the essentials of AWS cloud services and the requirements to succeed in this examination. So let's embark on this journey together, because with this training, you will gain the skills to ace the CCP examination and show the world that you have a future in tech. Do you have a future in tech? I have a future in tech. I see my future in tech, and I believe you have a future in tech. Let's do our best to succeed in this course, succeed in this exam, and show the world that you have a future in tech. If you believe strongly that you have a future in tech, please type in the chat, I have a future in tech. I have a future in tech. I have a future in tech. John has a future in tech. Lucretia has a future in tech. Enoch has a future in tech. Amon, Norbert, Asa, Prosper, Agului, Nonfanello, Lois number 2, Mustaf, Wildom, David, Atto, Hillary, Kebonye, Dachomo, Israel, Crankson, Laureen, Joseph, Grayson, Marvelous. You have a future in tech. I believe strongly that you have a future in tech. And this is the time to build the foundations for that future. I want to tell you that there is a higher version of you waiting for you in the future. There's a higher version of you that is successful, a higher version of you that is intelligent, a higher version of you that is well educated, waiting for you in the future. The level of education you have today is different from what you had 10 years ago. Today, you are a different version of yourself than you were 10 years ago. A lot has changed. What I'm trying to tell you is that there is a better version tomorrow, and we need to align with that version. By the time tomorrow comes, we want to be so much better. By the time tomorrow comes, we want to be able to compete on the global market. We want to be able to compete on the world stage. We, the African tech professionals, we will compete at the world stage. There is a version of you waiting. And for you to get there, you need to pay a price. You need to study. You need to prepare yourself. You need to build yourself. You need to go through training night after night, day after day, and get yourself ready to do great things and to advance in tech. So welcome to day 2 of our AWS Cloud Computing Training with AWS CCP certification. Today, we want to get into the world of AWS. And so we are going to begin an introduction to AWS, take a peek into the history of AWS, and spend today talking about the vast global infrastructure of AWS. The goal of this lesson is to build understanding of the infrastructure and the setup of AWS. This is a major requirement in the examination. And so by the time we are done with this lesson, you should have a clear understanding of how AWS is set up around the world. So open your mind and be ready to connect every dot and get the understanding. If you missed the previous lesson, you can find it on your platform. And this lesson too will be available. And so you can go over this lesson and have clarity. It's not enough knowing the names of certain terms, but what is important is to be clear with the exact structure of the AWS infrastructure. And that is what we are going to cover tonight. So let's start with introduction to Amazon Web Services. Amazon Web Services, or AWS, is a leading cloud service provider established by Amazon that offers a vast array of computing resources and services over the internet. So what AWS is doing is to offer several computing resources over the internet, and that is what we call cloud computing. Launched in 2006, AWS has grown into the largest cloud provider in the world, used by organizations of all sizes to host applications, store data, manage computing resources, and build solutions. Companies of all sizes rely on AWS today for their cloud services. AWS, just like the story I told you, offers over 200 fully featured services that enable businesses to build, to deploy, and scale applications quickly, all within a flexible pay-as-you-go model. So in this examination, you need to understand the pricing model of AWS, and we have understood clearly that AWS uses a pay-as-you-go model, and instead of capital expenditure, AWS offer variable expenses. We are going to take a look at the history of AWS so that we will discover some key details about how it all started. We are going to discover that this giant AWS solution that we have started because AWS or Amazon wanted to solve their own complex IT problems. And in solving their problem, the idea came in a meeting somewhere around 2003 that why don't we build this thing in a way that other companies can also benefit from? And so Amazon Web Services was launched in 2006 by Amazon, originally as an extension of Amazon's internal IT infrastructure. So the original idea was to build Amazon Web Services as an extension of Amazon's own IT infrastructure. The initial idea was to help Amazon itself manage its complex web infrastructure more effectively and efficiently. However, in a meeting during the planning, Amazon recognized that many companies would benefit from their expertise, their scalable, on-demand IT resources. And thus, AWS was developed as a commercial cloud platform instead of a private platform for just one company. And they started with Elastic Compute Cloud. Elastic Compute Cloud, EC2. And as we go through AWS, we are going to understand how they name their services. And so over here, we are seeing Elastic Compute Cloud. This Elastic Compute Cloud would have been ECC. But instead of ECC, how did they call it? Elastic Compute Cloud. So if you are abbreviating this, it should have been ECC. But how did they call it? Who can tell me in the chat? So instead of ECC, they decided to call it EC2. And then we have Simple Storage Service. Instead of SSS, they decided to call it what? Instead of SSS, they decided to call it S3. The same as we have www.adomainname.com. www can also be called W3. So S3 stands for Simple Storage Service among their first offerings. AWS quickly gained traction due to its pay-as-you-go pricing model, which allowed businesses of all sizes to access powerful computing resources without significant upfront investment. This shift toward a utility model for computing marked a turning point in IT, allowing startups, small businesses, and enterprises to leverage technology more flexibly and affordably. So this gives us an idea of the history of AWS. They tried to solve their own complex problem because AWS was growing and expanding. Sorry, Amazon was growing and expanding rapidly, and they needed a solid solution for their complex IT systems and their IT problems. And so they built AWS and made it public for all businesses to benefit from their expertise. When Amazon started, Amazon paid a lot of attention to customer service and paid attention to growth and what to do to make life easier for customers. That is why Amazon itself grew so well and so fast. And they brought that same discipline into AWS, and AWS has also been growing. And the pricing model is fantastic. Companies love it, and AWS is growing. Today, AWS covers or provides over 60% of the revenue of the company. AWS gives them more revenue even than Amazon, the giant e-commerce company. And so sometimes solving one problem for yourself can lead to a business that a whole lot of people will enjoy. The founder of Amazon and AWS, Jeff Bezos, is currently the richest man in the world. He's worth billions and billions and billions of dollars. One time in an interview, I heard him say that AWS gives him a lot of billions of dollars. And AWS is a significant part of his net worth. And he said something else that is remarkable. He said that AWS was built with partners and shareholders. And these billions that AWS gives him, he only has a small percentage, even though it is the largest among all the shareholders. But the revenue from AWS has made all the partners and all the shareholders billionaires. And so he said, what we have built has changed the lives of so many. And all those who joined us to build AWS have become billionaires. He has less than 30% of AWS, and yet he's the world's richest man. And all those who built this company with him, they are all billionaires. So what is the significance of AWS in the cloud industry? AWS actually pioneered the modern cloud industry and remains a leading force due to its innovation, breadth of services, and their global reach. AWS significantly changed how organizations approach IT infrastructure by offering a scalable, flexible, and cost-effective alternative to traditional on-premise hardware.
And then, to the other one too.
So when AWS started, the other cloud companies had not started like AWS. So AWS actually pioneered what we know today as the cloud industry. They launched in 2006, and they still remain a leading force. And as a matter of fact, the leader in the cloud industry. So when we talk about cloud computing, AWS as a pioneer remains the leading cloud provider in the world. AWS is number one. That is remarkable. After 18 years, AWS is still leading. This tells you what is behind this company and the force behind the innovation and all that AWS is building. Today, AWS remains a leader with a vast global infrastructure and over 200 services, helping businesses optimize costs, improve performance, and stay competitive in a digital world. Its impact has made cloud computing a fundamental part of modern business. One of the reasons for AWS's success is their vast global infrastructure. Their global infrastructure. Their global infrastructure. And this global infrastructure it defines their network and their setup across the globe. And this, the understanding of this global infrastructure is a major requirement to understanding what AWS really is. And so today's lesson is going to be about the global infrastructure of AWS. The global infrastructure. So what I want you to do right now for me is to type AWS global infrastructure. AWS global infrastructure. Let me see who can put it in the chat for me first. AWS global infrastructure. AWS global infrastructure. Thank you, Yvonne. AWS global infrastructure. AWS global infrastructure. That is wonderful. So this lesson is going to give us that understanding and is going to help us have a clear picture of this global infrastructure. And before we get into this global infrastructure, I'm going to play a short clip. And after that, we will get into the global infrastructure. Now, this global infrastructure, your job is to build a clear picture of this global infrastructure. Your job is to have a clear understanding of the global infrastructure. So Once we begin, I want you to picture the layers within this infrastructure and the hierarchy of the components within this infrastructure. And hopefully by the end of this class, you'll have a clear picture which will help you learn AWS very well. So let me share this particular video in VLC so that we can get the sound much more clearly and continue with the rest of the course. So let me share my screen again. And let me know if you can hear the sound when it starts playing. Let's pay attention to this video. We've watched it before, but we need to pick some key details from it again.
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies, so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business, such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers, so you can focus on what matters most to your business.
All right. So you can focus on what matters most to you and your business. So in this lesson, we are going to look at the vast global network of AWS. This is what we are going to cover today. And our job is to get a picture and understand what this infrastructure is about. That will give us a strong foundation to be able to learn AWS and understand it very well. And so this vast global network is what we are going to take a look at today and understand what this means. So let me share my screen again and show my slides, and we will continue. Okay. So we want to talk about the AWS global infrastructure. Now, we need to understand that AWS global infrastructure is the backbone of AWS. And that is what provides a reliable, secure, and scalable network of data centers worldwide. And so what I have highlighted here is network of data centers. This means that this global infrastructure is made up of a network of data centers. And so for us to understand the global infrastructure, one of the key components of this infrastructure is what we call the data centers. When we started this training, we've been using the electricity company as an example, and we have been relating it to cloud computing. Now, if you visit the electricity company and where they do their operations from, their actual operation center or operational center, you are going to see all the machinery and all the infrastructure that they use to generate electricity, that they use to transmit electricity. When it comes to transmitting electricity to every home, it is not a small infrastructure. They have regions where they have transformers located. And if you've studied a little bit about electricity, you realize that they send massive amounts of volts into a region. And in that region, they have devices that will step the voltage down and distribute accordingly. So that in your home, for example, in Ghana, you only get 220 to 240 volts. If you have more than that, you have too much power and it can destroy your equipment. But from their transmission center, they don't transmit just 220 to 240 volts. And so for them to connect the whole country, it takes a massive setup of incredible devices that begin from the generating machines at the dam and in their operation center into all the centers they have and across their network and all the wiring they have done in the country. Think of the wiring the electricity company has done in the country. The network of electrical poles and electrical transmission cables that connects the whole country. It is massive. Now, AWS has an equally massive setup, but not just for one country, across the globe. That is so vast and so huge that we need to get an understanding of what makes AWS work. And one of the key components is what we call the data centers. Please put data centers in the chat for me. Data centers. Please put that in the chat for me. And so today we will have a picture of a data center and get a feel of how the data centers look like. These are massive buildings that contain all the AWS machines and their engineers and everything AWS uses. And they are spread all over the world in a vast network. And although the data centers are the main operation centers, the structure of AWS begin with what we call regions. And so the AWS global infrastructure is composed of regions. Please type regions in the chat for me. So for you to understand AWS, you need to understand that it begins with what we call regions. And then it moves to what we call AZs or availability zones. Please type that as well. If you have typed the regions, then type availability zones. If you have not typed regions, then type regions first. Availability zones. And so what we are going to do tonight is to get an understanding of what we call regions, and then get an understanding of what we call availability zones, and then get a clear picture of what we call data centers. And so the components of the AWS infrastructure is made up of all of these. We have regions, availability zones, data centers. Not only that, there is another very, very important component that is called edge locations. Please type that in the chat and we are done. Type that in the chat. Edge locations. Let me see that in the chat. Edge locations. Edge locations. Thank you, Amon. Thank you, Atov. Thank you, Lucretia. And now you guys are always fast and following. So I'm going to ask you a simple question. How many components make up the global, make up the AWS global infrastructure? How many components? There are 4 components, all right? So tonight, before you leave this class, make sure you have a clear understanding of what a region is and what an AZ is, what a data center is, and what an edge location is. Once you have this, then you got it. And this will form the foundation that the rest of the training will be built upon. So let's start with regions. Let's start with AWS regions. Now, we need to understand that AWS has actually set up themselves strategically and intentionally across what we call regions. Now, these regions are geographical areas. So when we say regions, we are not talking about machines. When we say regions, we are talking about areas around the world where AWS has actually built clusters of data centers. All right. So there are regions. I'm going to explain that. As of November 2024, today, we are in November 2024. AWS has 34 geographic regions in the world. All right. So today, as we speak, AWS has how many regions? How many regions do they have now? They have 34 regions. These regions are in areas such as North America, South America, Europe, Asia Pacific, the Middle East, and Africa, with announced plans for 6 more AWS regions in Mexico, New Zealand, the Kingdom of Saudi Arabia, Thailand, Taiwan, and the AWS European Sovereign Cloud, whatever that means. So this is what we mean by regions. And let me give you a clearer picture. This map is the actual map of the AWS global infrastructure. And the dots you are seeing are the regions. So what at all are the regions? That is what we are learning now. Now, who can count the red dots? How many red dots do you see? Who can count them? Now, Fanello is very fast. And so there are 6 red dots, not 5, 6. This tells you that there are 6 additional regions that are yet to be launched. And if somebody has a time, count the green dots and tell me how many you see, if anybody has a time. So in talking about the vast global network or infrastructure of AWS, this is the starting point, regions. But then, for us in this class, our job is not just to hear the term regions, because this is a terminology that AWS is using. Regions, availability zones. Our job is to get the right picture of the regions. So what exactly are these regions? Very soon, I'm going to take you to the link on this slide where you will see the actual website where AWS publishes their regions. But then, what we have to understand is this. When we talk about a region, I have zoomed my screen. I don't know if it is zoomed for you, probably because of how I have shared it. You may not see it zoomed. Is it zoomed? All right. Let me explain it in this way, and then we'll look at the website. We can all see the Africa map here. Now, even though we are seeing dots on this global infrastructure, these dots are not really dots. They are regions. They are large geographical areas So the understanding you need is to see regions as a vast area. So let me give you the idea you should have. Let's take Africa and let's divide Africa into 5. We have West Africa, we have Northern Africa, we have East Africa, we have Central Africa, and we have Southern Africa. So I've divided Africa into how many parts? Who can tell me? Sometimes the question I ask is just to help you to follow what I'm saying. So I've divided the whole of Africa into 5. Now, picture each of these as a region. That is what you should understand about what we are learning tonight. And so if I say West Africa, I'm not talking about one city. I'm not even talking about one country. Who can give me 3 countries in West Africa? 3 countries in West Africa. Who can give me 3 countries in West Africa? Anybody? We have Ghana, Nigeria, we have Togo. Wonderful. This means that in a region, there are multiple countries using this scenario that I am giving you, not the AWS region. I'm just trying to give you the right picture of regions, the AWS regions. And as we move forward, you are going to understand it. Now, in Eastern Africa or East Africa, give me 3 countries. Give me 3 countries in East Africa. So in East Africa, someone will say that we have Kenya, of course, Uganda, Rwanda, Tanzania. Wonderful. Wonderful. So now let me take you to this website, and then I will give you a clearer picture of what we are talking about. And so whenever we say AWS region, you are not supposed to think of a dot or think of a city. No. The AWS region is a large and a large area, a geographical area that has multiple clusters within it. And we'll be looking at that. So let me share this with you first. Let me share my screen and show you. All right. And so this is a website. This is an AWS website. And it is called the AWS Global Infrastructure Map. This is the same website I captured into my slide. And you can see that we have the regions over here. Some of the regions with some of the regions, you will see that they have specific availability zones. And so after talking about regions, we are going to move to what is called availability zone. So look at this, Canada West. When we say Canada West, We are not talking about one city. We are talking about a vast geographical area called Canada West. Canada West is a region. How many availability zones are within Canada West? If you can see my screen. This is why I asked you to tell me how many countries we have in West Africa. I'm just using that to explain this. This means that after we locate a region, we are going to realize that within a region, there are multiple AZs. Let me check this region. This particular region, how many AZs do you see? I see 6. I don't know. Wow. Now, look at the date they launched this AZ. Northern Virginia. When did they launch it? 2006. Wow. This means this is one of their oldest regions. Let's look at the Canada Central. When did they launch Canada Central? That means after 10 years before they launched this. Over here, wow, Canada West. What's the date? Canada West. 2023. That's interesting. And let's see this region. When did they launch this region? Mexico. When did they launch Mexico? Mexico is coming soon. So the dots you are seeing, they are actually regions. There's one region in Cape Town, launched 2020, with 3 availability zones. Wow, that's interesting. So now let's read something here. It says that AWS, the AWS cloud spans how many availability zones? What do you see here? How many availability zones? This tells us that there are more availability zones. And so when we say that there are 34 regions, don't think that AWS has only 34 branches. Not at all. These regions are vast areas. And each single region has multiple AZs. So if you put all the AZs together, they are 108. And it is announced that 18 more AZs are about to be launched. And how many more AWS regions are about to be launched? So very soon, we are going to have 40 regions. And the 6 that are about to be launched will be launched in Mexico, New Zealand, the Kingdom of Saudi Arabia, Thailand, Taiwan, and the AWS European Sovereign Cloud, whatever that means. Now, on this map, I'm able to even click on them on the continent. Let's click on the continent and see. So on the continent of North America, the AWS cloud in the whole continent of North America has 25 availability zones within 7 geographical regions. Okay. This means that in North America, there are 7 regions and 25 AZs with 44 edge network locations and 2 regional edge cache locations. So by the time we are done with this lesson, we are going to get an understanding of what a region is, what availability zones are and what edge locations are. So now you can see that we only have 7 regions. And we have, these are the 7 regions. So we have Northern Virginia, it has 6 AZs. So this is 1 region, 6 availability zones. Second region, 3 availability zones. So 9. We have Northern California or North California, 3, making it 12. We have Oregon, 4, making it 16. We have US East. And I remember US East, US West, US Central so well because in my host9 hosting server, anytime I'm setting up an account, I decide where to host it, which region to put it. So in our webmaster class, I mentioned things like this. Wow. So plus this 19, this makes it 22 and 25. So there are 25 availability zones. US East, US West, US Central. But look here, we have several other locations, but these ones are called edge locations. What in the world does it mean? In this lesson, we are learning what regions mean, what AZs mean, what data centers mean, and what edge locations mean. Let me click here in this region. I'm calling it region, but it's a group of continents. We call it the EMEA, EMEA, and that is Europe, Middle East, and Africa. So the AWS cloud in the EMEA region, Europe, Middle East, and Africa has 36 availability zones within 12 geographic regions. So there are 12 regions, 36 zones. This means averagely there are 3 with 39 edge network locations and 2 regional edge cache locations. Wow. So you can see here, so Cape Town is right here as a region. That's wonderful. And there are 3 AZs. Now let's look through the edge locations and let's see how many African countries we will find. Please check for me. If you see any African country in the edge locations, please let me know. Let me know. If you see any African country, let me know. Keep checking. Nairobi is there. Where's Nairobi? All right. So I can see Nairobi, Kenya. So Nairobi has an edge location. Then I can see Lagos, Nigeria. Wow. Lagos, Nigeria. And again, I can see Cape Town, South Africa. Cape Town, South Africa. That is wonderful. So at least we have seen 3 edge locations in Africa. And by the time we are done with this course, we are going to have a clear picture of what a region is, what AZs are, and what the data centers and edge locations are. Let me share my slide again, and we will cover a few more and take a short break. All right. Now, these regions are separate from each other, ensuring geographical redundancy. So yesterday, or in our day 1 lesson, we talked about redundancy. And these regions are strategically separate from each other to ensure geographical redundancy. What do you think this means? If we say that they are separate because We want to ensure redundancy geographically. What does that mean? How do you understand it? How do you understand this? In the morning class, I allow someone to speak. So if you want to explain this, please raise your hand and I'll allow you to tell us what that means. What does it mean when we say they are separate from each other to ensure geographic redundancy? Okay. Anybody? All right, so we have Valentine. Let me allow Valentine to speak. So Valentine, just unmute yourself and tell us.
Yeah, good evening, sir. Yes,
Good
so geographical redundancy is such that it will protect against loss of data. So it allows the applications to be hosted on multiple locations, on the multiple data centers, so that in case one is down, one is still available, so that the customer's data is not lost and they can continue the services for which reason they've subscribed to AWS.
Wonderful. So this is exactly what it means, except that here we are not talking about data centers per se, even though they are data centers in the regions. We are also talking about the regions themselves being separate, because in that whole region, they have prepared against disaster in the whole region, not just a single data center. So the picture we are building here is that we are going to discover that within a region, we have clusters of data centers, not one. And these data centers alone are huge, massive buildings. But then, even within the regions, we have another component before the data centers even come in. So the regions separate each other, are separate from each other to ensure geographical redundancy and allowing customers to also choose where to host the application. So there are several reasons and several benefits of the separation of the regions, because you can decide where to host based on factors like latency. We talked about latency yesterday, and also based on factors like compliance and data residency. Sometimes in certain regions, data is not supposed to move out. And so with AWS, there are certain services that you can intentionally choose which regions to deploy your application to. There are certain contents that are not allowed in China. And there are certain things that are not allowed to leave China. And so when it comes to regions, you can intentionally choose which region to work with. When we get to AZs, we'll talk about the same kind of idea. So there are several reasons why we have the regions created: for redundancy, for latency, for compliance, and for data residency. Now, each AWS region has a unique code, like US East 1. Please type that for me in the chat. US East 1. And this stands for Northern Virginia, USA. US East 1. And so when we get into our AWS account and we want to set up any of the services, we may be asked to choose which region or which AZ we want to set up in. So the knowledge we are gathering today is helping us understand the structure and also to let us know the naming convention of these regions. Once you get into AWS, you'll be seeing this. Each region operates independently of other regions. Wow. Which means resources and data stored in one region are not automatically replicated to another region unless specifically configured to do so by the developer, the solutions architect, the cloud engineer, the company, the customer. So when you are setting up your AWS services, you can intentionally choose which region to configure or to set up or to deploy to. This independence allows users to select specific regions based on factors like proximity to their end users, compliance, pricing. This tells you that there are certain services that cost differently depending on the region. In certain regions, certain services are cheaper. The same services are expensive in other regions. So you can make the decision where to deploy your service. So as students in this particular course, we have to understand certain key things. How the structure looks like, and we are also learning the reasons behind the structure. The reasons behind the structure. And when it's time to set up your AWS, you are going to be seeing all of these, and now you understand what it means to choose a region and why you choose a region. Now, each region consists of multiple availability zones or AZs, which are physically separate data centers within that region, providing additional fault tolerance and high availability. Okay, so what do we mean by AZs and data centers? So once we get into availability zones, we are going to clarify that. So when it comes to regions, for example, the US East, which is a North Virginia or Northern Virginia region, is a geographical area where AWS has multiple data centers organized into separate availability zones to serve customers in that part of the United States. All right, so the picture is coming. At least now we know what a region is. We know that the regions are separate from each other for various reasons. And we know that when a customer is setting up their AWS services, they can choose which region to deploy the applications to. And there are reasons behind that. So let's understand all these theories and all these key points. But then the main goal of tonight's class is to draw the right picture of the global infrastructure. Right now, we have an idea that there is a vast region, and the region, within the region, there are other things that we are yet to look at. But then in the whole world, we have understood that there are 34 regions. 6 will be added soon. So AWS is made up of these 34 vast areas. Now, in a single area, we are going to discover that it is also made up of multiple availability zones. We'll take a short break, a 10-minute break. When we return or resume, we will get into AZs, and then we'll get into data centers, and we'll end the lesson talking about edge locations. So let's stretch, and we will be back in 10 minutes. Thank you very much, and I'm going to see you in 10 minutes time. All right, so welcome back, everybody, from the short break. Are we back from the break? Are we back from the break? All right. Thank you so much. So let's continue and move to the next component of the AWS global infrastructure. This is referred to as the availability zones. Now, the availability zones or a single AWS availability zone refers to one of the multiple zones within an AWS region. This means that within a region, there are multiple availability zones consisting of a single or a group of data centers. Now, what does this mean? And as we are reading this, I am picturing how this looks like. And what this is saying is that within a region, you can find multiple availability zones. And each availability zone, a single one, consists of either one, which is a single, or a group of data centers. So now the picture we are getting here is that the moment you enter into a zone, an availability zone, you will find a group of data centers, or you may find just one data center in an availability zone. Each availability zone has its own infrastructure to ensure fault tolerance and high availability. Of course, we have understood that there are multiple AZs in each region to provide redundancy and resilience. Now, if one availability zone faces issues, others in the same region can take over. So we have seen the reasons behind the availability zones. So if one AZ fails or faces issues, others in the same region. So the AZs within a region, they work together to ensure redundancy or to provide redundancy and resilience, ensuring that applications remain available and reliable. This means when there is a fault, customers will not even know that something happened because other AZs will immediately take over. This setup also allows customers to distribute their resources across AZs for better scalability and disaster recovery. And so in AWS, there are certain services that you have to intentionally select the availability zones. And there are certain services that will be automatically distributed across multiple availability zones. So once we get into the AWS services, we are going to know which ones are automatically distributed across and which ones you are allowed to select specific AZs. But what I'm excited about is that now we know the difference between a region and an availability zone. And before we end the class, I want to find out how you have understood it. The understanding we have given so far is that when you pick one region, within it, there are multiple AZs. And these AZs are distributed for better scalability and disaster recovery. So let me give you a clearer picture here. Look at this diagram carefully and tell me how many regions you see. How many regions do you see? All right. So question says there's only one region. Okay. So here we have singled out one region. All right. That's wonderful. Now, how many availability zones do you see? How many availability zones do you see? There are 3. This is beautiful. This is exactly what we are trying to communicate. All that we'll be doing tonight is just to paint this picture to you. When we went onto the map, you saw that when you put the pointer on a region, they tell you the number of AZs. Over here, we have seen that there are 3 AZs. And if you look at the box at the bottom, you'll see that that box represents a data center. So my question is, in availability zone B, how many data centers are there? In availability zone B, how many data centers? There are 2. How about availability zone C? How many data centers are in zone C? There are 3. This diagram here, if you are able to understand it, is everything we are trying to teach you tonight for you to build the right understanding of the AWS global infrastructure. Now, with this picture, multiply this 34 times and place them across the world at the specific places that the AWS regions are. And you have the AWS global infrastructure. This is what the examination wants to be sure that you have and you understand. Don't be confused when we mention region. Don't be confused when we mention AZ. And don't be confused when we mention data centers. You can see that data centers are within the AZ. And there are multiple data centers. Some have more than others. As a matter of fact, when it comes to the data centers, because the data centers are the real operational centers, AWS has decided not to disclose the exact number of data centers. And not to tell us the location of the data centers. So AWS does not want anyone to know where these massive buildings called data centers are located. They don't want us to know. And even those who know, there are a lot of security protocols to be able to approach one. Because the data of sensitive companies are within these locations. So there's a lot of security around the data centers. So picture this. If you can understand this diagram, then you've gotten the whole idea. This is the architecture of the global infrastructure. And then, within a region, the actual operational centers are the data centers. And so sometimes when you are reading, you may be told that AWS regions are geographical areas where there are multiple data centers. That is what you may read. As a matter of fact, in our first slide about regions, we read something similar to that. But for you as a student, don't be confused about how exactly it looks. Of course, it is true that the region has multiple data centers. But then you understand that these data centers are actually in zones called availability zones. Does this make sense to anybody in this class? I just want to know if only one person, at least one person, understands this. Does it make sense to you? Wonderful. All right. But then I'm going to mention that you don't yet fully understand the AWS global infrastructure. We've made a lot of progress because this diagram clarifies everything. And if you multiply this by 24, 34, you are getting a better picture of the global setup. But then You don't yet understand the structure or the infrastructure until we talk about edge locations. Right now, after we conclude availability zones, talk about data centers. But then what I'm saying right now is that after learning about data centers, we are not done. If we don't talk about edge locations, we don't understand AWS. We will only understand AWS when we add edge locations to this map. Understand how AWS is really set up. So this is what we have already explained. For example, in the US East North Virginia region, there are multiple AZs, such as US East 1A, you see? Then we have US East 1B, US East 1C. You remember the naming convention we came across? US East 1 was the name of the region. And now we are seeing that there is US East 1A, US East 1B, US East 1C. So if you enter into AWS and you see a name like US West 1B, the question is that a region or it's an AZ? Is that a region or an availability zone? It's an AZ. Thank you. So just be smart and pick these little information. Now, these are separate data centers, and you see that we are talking about data centers, but they are actually availability zones that are geographically isolated but connected through high-speed networking. A customer could host their web applications in US East 1A and have a backup in US East 1B. Wow. So if one AZ encounters a failure, the application can automatically switch to the backup AZ, ensuring continued service without interruption. So the thing is, until you really understand the clear picture, there are a lot of things that you read or you hear that you will have the wrong assumption, that you will picture wrongly, or you will not understand. That is why I'm trying to tell you again and again that this lesson is, the goal of this lesson is for you to get a clear picture. And we are almost there. Let's move on to what we call data centers. One more time, please type data centers in the chat. And as you are typing data centers, I'm going to play a video about the AWS data centers. There are two of them. I'll play one now. And before we end the class, I'll play another one. Actually, before I play that video, let me show you something else. I'm going to take you to the second website. I'm going to take you to the second website. And this second website from AWS gives us a picture of how the data centers are. If you get a chance to see a data center, which is very difficult, but possible, you are going to find engineers, technicians. You are going to find racks. These massive containers are called racks. Please type racks, several racks. And what this engineer is holding is called a server. So this is a web server. And within this massive building, there are thousands and thousands and tens of thousands of servers. These are the servers that power the internet. One day you'll work in a massive data center like this, frankly. So this website here gives us an idea of the data center. So this video here, I'm going to play this video so that we will get an idea of how the data centers look like. There are two data center videos I'll play. I'm going to play this one, and afterwards I'll play. So you see we have female engineers. Wow. And this video, listen to the video carefully. You'll hear all of them so satisfied with their jobs. They are happy with their jobs. And you can tell that they are well paid. You can tell that they are well paid. And you see that they too, they went through training to be able to get these jobs. So just like Caleb was saying yesterday, the time will come, you will also be working in a big company and being well paid. Listen to the video carefully, what they are saying, and you can sense it that these people are really satisfied. They are happy with their jobs. This guy here is a musician and a technician as well. And he's saying that he's not desperate to monetize his music career and trying to survive through music. So he's doing the music not because of money. So you can tell how satisfied he is with his job. So let's take a minute and watch this short video. And after that, we will get a clear picture of the data centers of AWS. There are two of them. This is the first one. After this one, I'm going to play another one, the course of the lesson, before we end the class on time today or tonight. Let me make sure I get it now.
When I was young, I couldn't wait to see the world, see everything and know.
My favorite toy as a little kid was this blue CD player stereo. I loved to bring the stereo into the bathroom and sing Marvin Gaye loud as I could. I've had a lot of different jobs. I worked in the blueberry fields and I weeded onions. I worked on a farm.
I've seen lots in New York City, been around the world, and I know it's pretty, but you know I couldn't wait to get back to my hometown.
Amazon was pitching a data center technician kind of boot camp. It sounded like a great opportunity, and I figured, you know, might as well give it a shot.
Learn a little about love and a little about life, and I got a good job and I met my wife, and I settled down off in my hometown.
Being a single mom, you go where the money is. I was working security, and before that was a lumberyard. I've also been a dental assistant and worked in old folks' homes. I love fixing things and I love learning new things, but I didn't have any technical background. I wanted to prove to myself that I could do any job that I set my mind to. Now, did I know that I would be as lucky to get this job? Absolutely not, but I knew I could do it.
My journey to AWS started straight out of Hermiston High School. I wanted to do a trade, like a diesel mechanic. One of the options was the data center technicians program that was offered at BMCC, which is our local college. Miss Monroe, she's the counselor for Hermiston High School. She mentioned this program to me and she helped me get in.
My job was to mentor students. I was the one that you met with. Did you know about the data center technician?
You're the one that told me about it. And the funny part is, like, as soon as you told me about it, I was like, okay, that's it.
I've been waiting for a long time. Been searching for my own kind.
I came into AWS as what's called a rack install technician. So all the logical and physical ingestion of the computing equipment, getting that online. Eventually, I was able to get into the manager and training program. Being able to create music is awesome. It gives me a feeling that I don't get anywhere else. I don't get too emotional very often, but music can really touch a part of me. I'm glad that I don't have to make a living off of music because it's something that I really love, and I don't have to stress about it becoming work.
What I love best about my job is the opportunities that I get, learning new things. In the morning, we see how many racks were coming in. We sit there and put on all the whips. We walk our whole building. We check everything for alarms, make sure everything is working the way it should. And then we go into the red zone.
One of the most surprising things about working for Amazon is you just don't really know what's going to happen next. All of a sudden, it's like, oh, hey, there's a new type of rack that came in. And then you have to learn all the technology that's in that one, and you got to be ready to troubleshoot it.
I really like when something breaks, when we get to actually take it apart and fix it. That's the most exciting part of my job, I think.
So normally the birria is supposed to be in a stew, but the queso birrias they're pretty good, so I like cooking them that way instead. I work with my brother.
Fidel kind of pushed me to look into DCO. I've enjoyed it. There's a lot of technicality, and it's just a lot to learn every day. And obviously working with this big head over here, so.
Before, there weren't a ton of options around here because there wasn't that growth, and it's allowing people to stay, close to their family, close to home.
I don't have to stress as much about bills. I don't have to live in a low-income housing anymore. I'm able to take my kids to the ocean, kick back and watch a movie.
I like the people I work with. I like my position. I like what I do. I wake up every morning and I feel good about going to work.
It makes me excited to see, because I can tell it's what you were supposed to do.
Yeah, that's what it feels like.
So if you like peace and simple living, won't you come and see what you've been missing, Lord? And I'll be waiting in my hometown.
Thank y'all so much. Ain't it such a nice place to live?
All right. So this is really a nice place to live. Right? You can tell how excited they are about their jobs, how they are working, how they are fixing things. This is really, really nice. Look at the data center. That's the building. It's a massive complex, and this is just one. So these buildings actually power the internet, the web that we know it. These are physical facilities. This is an area view, and this is a giant building. Yes, this is really, really massive. And this is just one. So at least we know that AWS has 108 AZs. And each AZ has multiple data centers. And again, AWS is not interested in telling us much about the data centers because they don't want people to know much about it. Because this is where the work really takes place. So the AWS cloud computing we are talking about, that is what you are looking at. This is the cloud. Yesterday's video, the video said that the cloud refers to a massive building that contains thousands and thousands of servers. That is true. So the AWS we are learning, that is what you are looking at. This is what makes the magic work. This is what makes AWS work. This is it. All the machines that do the work are here. All the brains, the people, the engineers, the experts, the tech people, this is where they work. That's so interesting. And it feels good to work at places like this. And so sometimes you just want to be part of something big and something meaningful and something that is really changing the world and something that is really making history. You want to be part of something. This is excitement. What excites people about getting jobs at certain places? It is so fulfilling being part of something big, being part of something big. And the beauty is that such places, they give free food, free laundry, a lot of free things. You can see how satisfied the workers are. You can see that lady saying that she doesn't have to live in a poor home anymore. She doesn't have to worry about money anymore. Now she can take time and go to the movies with her kids, enjoy her life. She's happy she got into the training, the boot camp for the AWS data center training. She went through the boot camp and she made it. As I'm saying this, I'm talking about you as well. You will also make it. I'm talking about you. I'm seeing you at high places. And I'm seeing you part of teams and companies that are making a difference. And one day, some of you will say that, I remember when we were studying at Rita Africa, Seth said that some of us will be working at places that make a difference. And you look back and you will know that I said it. And you're actually working at places that make a difference in the world. So let's look at data centers. And these data centers, just like we have seen that building, they are physical facilities where the AWS infrastructure that powers its cloud services reside. So the building I showed you, that is where what powers the cloud as we know it. That is where the machines are. This includes servers, networking equipment, storage systems, and other essential IT infrastructure that enable AWS to provide the scalable, reliable, and secure cloud services. You've already seen this picture from the website. This is so beautiful. So in the data centers, you see a lot of networking. So when I'm talking about networking, you can see all the network cables, all the network cables. You can see that everything is networked. So AWS tells you that they take care of the data centers, they take care of the networking, they take care of the storage, they take care of the virtualization, just like we discussed yesterday in the IaaS diagram. That is what we are talking about. You can see for yourself that they've done serious networking. Wow. Sometimes when you understand what it means for something to be done so perfectly, and you see what people have done, you are so amazed. Look at how clean the networking is done, the wiring. Wow. Out of the 108 availability zones, AWS doesn't disclose even the number of data centers. So whatever you assume is probably wrong. This means at least we can assume a minimum of, what do you think? A minimum of how many data centers around the world? If there are 108 availability zones, we can tell a minimum, but then we will not know the actual number because AWS doesn't want you to know. So we'll have a minimum of, what do you think? All right. I was hoping you'll tell me. No, 180 is too small. There's 108 AZs. 3,000, I think it may be too much. At least 300, 350 should be minimum. So if there are 3,000, maybe, but I think 2,000 is too much. It should be around at least 300, minimum of 300 and more. So I like what Enoch said. And Free Hats is giving us about, okay, 1,080, maybe. All right. So these data centers are located within the availability zones. So now I know that you understand it already. AWS has data centers spread across different regions worldwide. Yes. Ensuring that services are always available and reliable. So it's always about redundancy, latency, reliability, and all that. So, for example, in the US East, the North Virginia region, AWS has several data centers that are organized into availability zones, providing a secure and scalable environment for customers to run their applications. So now, this is what I want to tell you. When you are learning about the AWS infrastructure, you are actually going to be talking a lot about regions, availability zones, and edge locations. And when they are talking about data centers, they will talk about data centers as if we are talking about availability zones. And so when you are reading these things and you don't really know the reality, you may have a wrong understanding. So here, AWS has several data centers that are organized into availability zones. Now, to someone who hasn't taken this particular lesson, they may find it difficult to understand what this sentence really means. AWS has several data centers organized into different availability zones. For us, it is very, very clear. So we know that the zones are there, and within the zones, there are multiple data centers. And again, you may not read a lot about the data centers within the structure that we are building. But then, as we have taken this structure, it has become very clear for you to know the reality. But then, we will not finish this lesson, and we will never understand this lesson if we don't study about edge locations. So, the last part of this lesson tonight is to talk about edge locations. Please put that in the chat. I'll take a minute and play the last data center video. And after that, we'll talk about edge location. While I find the video and share and play it, I want you to type edge locations in the chat for me. So we learned that there are 4 components in this infrastructure. And we have learned about the first 3 regions, AZs, data centers. The last component is what we call edge locations. And once you understand edge locations, then you can now say that you understand the AWS global infrastructure in full. Let's take a minute and watch this particular video.
Amazon Web Services is an unrivaled colossus of the internet age, providing the computational horsepower underpinning countless organizations. From Netflix to BMW, Disney to GE, Tinder to the CIA. It earns tens of billions of dollars a year. And if you've used the internet at all lately, you've probably used Amazon Web Services without even knowing it. Join us today as we enter the belly of the beast and take a sneak peek inside an AWS data center. In stark contrast to its cardboard boxes, vans, trucks, jet planes, and warehouses, Amazon prefers not to brand its vast portfolio of gargantuan data centers. But these monumental server farms are the very guts of the firm's wildly successful AWS, that's Amazon Web Services division. AWS began life at a 2003 meeting in the lake house of CEO Jeff Bezos. The firm had just emerged strong from the dot-com bust, but Bezos' fast-growing retailer was having difficulties setting up and rolling out its own internal server capacity. A scheme promising fast, scalable server infrastructure was duly hashed out, and was swiftly identified, by the more enterprising young guns in the room at least, as a potential spin-off service Amazon could sell on to other companies. Fast forward to today, and AWS rakes in a whopping 60% of all Amazon profits. That's about $50 billion a year. How? By taking on other companies' tech problems in the cloud. If you're a startup in 2021, you no longer need to invest precious capital in vast banks of noisy, expensive servers and battalions of nerds to maintain them. You just rent time on Amazon's gear instead. That's the cloud. When you're busy, yay, you hire more gear. If you're quiet, whatever, you hire less gear. The actual gear in question is jealously hidden from prying eyes by Amazon. Even clients aren't allowed to poke around in the data centers they pay for, and their addresses aren't made public. But here's what we know. Take a typical site in Loudoun County, Northern Virginia. AWS is said to run at least 50 individual data centers in this region alone, covering several million square feet. Believe it or not, Amazon is planning on adding still more capacity in Northern Virginia. For instance, a 100-acre site near Dulles Airport the firm reportedly just shelled out a cool $73 million for. On entry to one such data center, let's say this giant nondescript box next door to a pet resort in Sterling, the first thing we notice is that security is the overriding concern for AWS. There's high fences, guards, and several layers of intrusion detection systems, most obviously cameras. When access is permitted to very limited people for very limited periods, two-factor authorization is required on at least 2 occasions during the visit. If a visit is sanctioned, this is extremely rare, visitors are accompanied at all times by at least one authorized member of AWS staff. Once this so-called perimeter layer is passed, the next stage of the data center is known as the infrastructure layer. This is where crucial systems like backup power, fire suppression, and most importantly, HVAC or air conditioning are situated. To maintain market dominance, AWS data centers cannot be allowed to fail ever for any reason. As such, water, power, telecommunications, and internet links are all designed with full redundancy. And keeping all those servers, as many as 80,000 in a single data center, running requires constant monitoring of ambient temperature and humidity to prevent overheating. If the worst should happen and a fire breaks out, a suite of systems involving water and gaseous sprinkler systems are rigorously maintained and good to go in a crisis. Past the infrastructure layer, and we're finally where the real magic happens, the so-called data layer. Security is even tighter here, with a secretive array of intrusion detection systems and even stricter review process for anybody going in or out. Even if something minor happens, for instance an internal door is held open slightly longer than usual, alarms are triggered. All access points are fortified with multi-factor electronic control devices. If a data breach, physical or virtual, is even so much as suspected, the relevant server is automatically disabled and shut down. These security systems are audited throughout the year according to a robust 2,600-point checklist supervised by external bodies. These external auditors can request access to anything in the data center, from humdrum logs to security footage or even the very cameras themselves. AWS staff are sometimes plucked at random from their shifts and interviewed about topics like the disposal of media, itself a process that's held to exacting and robust compliance metrics. Let's look at the hardware itself. In the midst of all this hypersecurity, it's maybe easy to forget that AWS data centers are fundamentally just enormous banks of servers. A typical AWS data center will hold anywhere from 50,000 to 80,000 servers, running on a combined 25 to 30 megawatts of power. It's said that AWS could quite easily double this size and make even bigger data centers. However, like everything Amazon-related, it's all a question of finely calibrated scale. Distinguished engineer and AWS VP James Hamilton told attendees at the company's reInvent conference in 2016 that beyond a certain point, increasing the number of servers and racks per center no longer lowers the incremental cost. At some point, the value goes down and the costs go up. And in our view, this is around the right number, Hamilton says of the data center size AWS usually goes with. Thrillingly, Hamilton employs the term blast radius to underscore the impact a failure might lead to in a much larger data center, hence the relatively modest dimensions. Still, 80,000 servers is plenty, designed to take in, according to Hamilton, some 102 terabytes of data each and every second. Significantly, the engineer also hinted that the bandwidth within the center is wildly higher even than that. Ever evangelists for vertical integration, Amazon have made great strides in streamlining and perfecting the servers themselves over the years. Unlike other co-location server infrastructure providers, AWS has a much clearer understanding of who will be using its hardware and for what. Removing this requirement to be versatile and generalist has enabled the firm to devise ever more efficient server architectures. When mundane software operations are translated on the hardware or even the very silicon of the chips, this can shave nanoseconds off of processing times. And at Amazon scale, that makes a big difference. Initially, AWS bought servers off the peg, as it were, from traditional suppliers. But steadily over time, the firm began developing its own single-depth servers, exquisitely optimized for airflow in AWS buildings running AWS software. AWS has even developed its own so-called Graviton chipsets since acquiring Israeli firm Annapurna. These Graviton chips, currently in their second generation with a third on the way, use the power-efficient ARM architecture. This represents a break from long-term Amazon partner Intel and its x86 architecture, and is said to give AWS clients 40% better price performance, essentially putting supercomputer-level power in the hands of regular commercial users. In terms of storage, a single standard-sized rack in an AWS center can hold 11 petabytes. That's 1 million gigabytes of data on 1,100 disks. Multiplied, of course, by many thousands of times across many hundreds of data centers all around the world. AWS routers, here comes the science kids, can run custom ASICs or application-specific integrated circuits that support 28 ports with 25 gigabit Ethernet connectivity. This diverges, fun fact fans, from the industry standard 10 gigabit Ethernet and 40 gigabit Ethernet networking speeds, but apparently, according to James Hamilton, offers economies of scale when paired together at 50 gigabit Ethernet. Networking between data centers, essential to provide security and backup for crucial client info, happens over Amazon's own private 100 gigabit Ethernet network, which connects the 25 international regions and 80 so-called availability zones across the vast AWS worldwide network. AWS even lays down its own private undersea cables. But back to our data center. Cooling is an overriding priority, and to minimize environmental impact, AWS, in particular in Loudoun County, Virginia, set out to use as much reclaimed water as possible. This stops the company hogging all the precious local drinking water, which would obviously be a PR nightmare. Loudoun Water, the local utility, are happy to provide this reclaimed water at a competitive rate. AWS pays serious taxes here. But it's worth noting that elsewhere, AWS has installed its own on-site water treatment systems. These prevent pipes clogging up with mineral sediment, which in turn causes costly hassle and delay. And if you think that's crazy, the company has even started developing its own power substations. All those servers use a fair bit of juice, so instead of waiting for slow-moving traditional power companies to develop infrastructure to keep all those all-important racks humming at all costs, AWS simply builds electric substations itself. Day-to-day operations within the data center are described by some ex-technicians as being akin to an ER department for computers. With that much hardware, inevitably things seize up, stop pinging, or require a reboot. Fault finding and upgrading equipment is left to a small army of techs who follow rigorously drilled playbooks that cover almost any conceivable eventuality. Metrics are set by supervisors, encouraging teams to complete tasks quickly and efficiently. Some have complained that the working environment is cold, and it's certainly very loud. In the future, we can expect to see more and even louder AWS data centers come online. From early 2020, a new AWS center opened in the Northern Virginia area alone every 3 months, totaling around 1 million square feet in footprint, and that's just one area. All in all, it's quite the numbers game. What do you think? Do these vast data centers get the credit they deserve for underpinning so much of modern life? Let us know in the comments, and don't forget to subscribe for more supersized tech content.
All right. So in this video, we've heard a lot about the data centers and we've gotten a lot of information. You can see that they are even laying their own undersea cables. They are building their own power stations. Unbelievable. Unbelievable. That is AWS for you. If you combine the lesson in day 2 with the lesson in day 1, you are growing in your understanding of cloud computing and AWS. And as we go through this course, you are going to learn everything you need to know to get ready for cloud computing, to excel in cloud computing. There is one last part of the global infrastructure without which you will not have the clear understanding that we need to talk about. This will require you to pay a lot of attention. Within 10 to 12 minutes, we should be done talking about it. But you need to be ready to accept new information and to open your mind. For the seniors, this should be very easy for you to understand because we've been dealing with something similar in our previous courses. Now, edge locations are also physical sites. Okay, wait a minute. Wait a minute. So, we are talking about edge locations right now. And already, we've said something very big. What do you mean? I thought it was all about the regions, the AZs, and the data centers. Edge locations are also physical sites. Across the world that are specifically and intentionally designed by AWS to provide what we call fast content delivery. Please put that in the chat for me if you heard me. Fast content delivery. Fast content delivery. So this is where the understanding of the remainder of the lesson is. Fast content delivery. Because of fast content delivery, AWS has what we call edge locations. What in the world are edge locations? I thought we talked about the data centers. So what are edge locations? Are they the same as the data centers? The answer is 1,000 times no. Beside the data centers, which are the physical buildings we saw, there are other sites. These sites are referred to as edge locations. What is the purpose of the edge locations? Their purpose is to provide fast content delivery. Okay, keep this in mind. This will come in your examination. What is the primary purpose of the edge locations? To provide fast content delivery. Are edge locations the same as data centers? 1,000 times, no. They are also physical sites. They are different. Now, third question. How does the edge locations, or how does the edge locations provide fast content delivery? How do they do it? They do that by caching data. Please type caching data. Caching data. Please put that in the chat for me. Okay, so what is caching? Okay, so just with this, we are picking up a lot of information. We've learned that the edge locations are also physical sites. Really? So apart from the numerous data centers, do we have other sites, other physical places? Yes, we do. Really? What are they called? They are called edge locations. What is their purpose? They have one purpose: to provide fast content delivery. How do they do it? They do it by caching data. And they cache the data, listen, closer to end users. For what goal? To what end? To reduce latency. Wow. Wow. So to understand just this sentence, you need to have an idea of what caching is all about. You need to have an idea of what CDNs are. Please type CDN in the chat for me. If you can hear me, type CDN in the chat. CDN. Wonderful. Just type it in the chat for me. So these edge locations, their end goal is to reduce latency by caching the data closer. They don't just cache it, they cache it where? Closer to the end users, so that there will be fast content delivery. Okay, let's continue. Watch this. Edge locations are part of AWS's content delivery network. Okay, AWS has something we call content delivery network. There is a network, or there is something we call content delivery network. This idea of CDN, this idea of caching, this idea of latency is something that we have already learned a little about, especially the seniors. This is exactly what Cloudflare does for you. You know why we use Cloudflare? We use Cloudflare to supercharge our websites, make our website faster. How does it work? By using their CDN, content delivery networks, to cache copies of our websites, so that our websites will load faster and our website will be served from edge locations closer to the end users to reduce latency. Wow, this is so powerful. Now let's come back to AWS. We know about Cloudflare, okay? If you have not learned about Cloudflare yet, you will. These edge locations, they are part of AWS's content delivery network, CDN, that operates through one of the AWS services called CloudFront. So in AWS, they have what we call CloudFront. In the Webmaster class, we learned Cloudflare. Cloudflare is not AWS. AWS has a similar system, but we call this CloudFront. Please type CloudFront in the chat for me. All right. Thank you, Quayson. So now I want you to refresh your mind and listen to me one last time. After this, we are closing. And just get this understanding, because I know you've not gotten it yet. Let me tell you what this means, these edge locations. Now, the actual sites where the data or the applications are stored is what we call the data centers. If you go to Cloudflare will tell you something. That we will use our CDNs and you don't have to change your hosting company. Why? Because we need your origin server. Okay, please type origin server in the chat for me. Origin server. Please type that in the chat for me. However you heard it. Origin server. So this particular phrase I've given you here, origin server, is really powerful. What this means is that the actual server that contains the content or the data is called the origin server. But the website may not be served from the origin server. So I'm going to give you the clear understanding. The origin server, let's take a website as an example, is where the website itself resides. The server that the webmaster bought and the server that you uploaded your website to. Technically, we refer to it as the origin server. If you use Cloudflare or CloudFront, what CloudFront will do is this. CloudFront will use another station called a CDN. And what Cloudflare will do, CloudFront will do is this. Let me use what we saw in the diagram or on the map. I remember when I went to the map, we saw 3 African countries, right? Who can remember them? The 3 African countries, who can remember them? All right. We saw that we have South Africa, Kenya, and Nigeria. Okay, now pay attention here. Yes. There is no data center in Nigeria. Yes, because there's only one region. And where's the region? The region is in South Africa. We know that the region is in South Africa. This means that there is no data center in Nigeria. But there is an edge location in Nigeria, which is a different setup with different hardware, with different infrastructure. So watch this. I am in Ghana. Listen to this carefully. If I want to visit a website that is hosted on AWS, probably that website is hosted in South Africa, in the data centers in South Africa, because the data centers are the actual sites where the real data exists. Listen to me again. The first time I ever visited a website, listen, the website will be served to me from the origin server. Where is the origin server located? Who can tell me? Where is the origin server located? The origin server is located in South Africa. So the first time I visit a site in Ghana, the website will be served from South Africa. But look at what will happen. This is where the understanding is. Nigeria will quickly step in. And Nigeria will say that, wait a minute, I have an edge location. And so, even though, since this is the first time, no problem, let's go to South Africa. But now that we have gone to South Africa, I'm going to store a copy of the website in Nigeria, because Nigeria is closer to Ghana. Now listen again. The next time I visit the website, or the next time anybody in Ghana visits that same website, the website will not be served from South Africa. Where will it be served from? The website will now be served from Nigeria. So what is Nigeria doing? Nigeria is just a caching station. It's just a copy station. So when we say caching, just like your computer, when you are browsing, the first time you go online, you visit a website, it takes time for the website to load because it is now downloading all the images and everything. But your computer does caching. Next time when you visit the website, it will load faster because some of the data are already stored on your machine. So it doesn't have to go to the server again. So watch this. This is where the understanding is. Nigeria has another facility, which is not a data center. That facility is called an edge location. That edge location, its job is to copy the website that was served from South Africa closer to Ghana. So that if anybody wants to visit the website, they will be served from Nigeria. So that latency will be reduced. So that the content delivery will be faster. This is what we refer to as fast content delivery. And so, apart from the numerous data centers, there are even more edge locations than data centers. Apart from the several data centers in the AWS global infrastructure, there are even more edge locations than there are data centers. And these edge locations are everywhere. Because of that, content is delivered so fast. So once you get into caching, this is the idea of caching. There is a station or a place closer to you that the data is stored so that you don't have to travel all the way. So the understanding we have gotten so far is that these edge locations, they are not actually data centers. So what do we have there? By caching data closer to the end users at the edge locations, AWS ensures faster content delivery. Of course, especially for static assets. So this is what I was going to say. Anytime we talk about caching, usually caching is done on static content that will not change. For example, a website, the static part of the website will be cached because if it is a dynamic content, then it means it has to be pulled from a database every time. And so for that, we need to go to the origin server. So I've given you another powerful terminology in networking and in CDN's content delivery network called origin server. If you go to your Cloudflare, you go to SSL, you'll see this origin server in your Cloudflare. Those of you who are using Cloudflare. So when we say origin server, we are referring to the original server where the actual content is. Then we also have the edge location that serves the content to you faster. And so assets that do not change, they are easily cached. But let's say if you are logging into your account and to pull data from your database, that will not be cached because it needs to connect to the database every time. But content that doesn't have to be stored from a database will be stored at the edge locations. These edge locations are actually the reason why AWS is so reliable, so fast, and so good, so successful. Unlike traditional data centers, regions, or AZs, edge locations are strategically placed nearer to end users to ensure faster delivery and minimize delay. They contain specialized infrastructure. Really, they also have their infrastructure, including cache servers, networking equipment, storage systems, and DDoS protection to handle high-speed data transfer and secure content delivery. Right now, if you are able in your mind to picture a region, to picture an AZ, to picture data centers, and to picture an additional set of sites spread everywhere that we call edge locations. And you can multiply this big picture across all the regions of AWS. Then you now have a clear understanding of the massive, monstrous AWS global infrastructure. Does this make sense to somebody in this class? Thank you so much. Thank you. Thank you. The last thing to take home is that these edge locations are operated through an AWS service we call CloudFront. So as we get into the AWS services and what they do, we are going to get a clearer understanding of what AWS is. And we all will be so happy that we have understood this. And when you write your examination, you are going to pass. Thank you so much. This brings me to the end of today's lecture and lesson and training, the end of day 2. We will get into the details in other lessons. Thank you. And I will see you in the next class. All the best. It's been a wonderful time. Have a good night. I'll see you later. Bye-bye.